Okay, hi. We're going to be doing page 53, number 16 here. Page 53, number 16 deals with a piecewise function f of x, which is equal to negative x sum of the time ax squared plus b sum of the time and 6 when x equals 0. And the question is, find values of a and b so that the function is continuous on its domain from -3 to 0. So the way we're going to do this is we're going to take a look at our one-sided limits, because as we can see, the function's made up of polynomial, polynomial. So these values are continuous on their domains. These functions are continuous on their domains, but what we need to do is we need to check to see, is the function going to be, for what values of a and b is the function going to be continuous at -2, and for what values of a and b is the function going to be continuous at 0, so that we don't have any jumps. If we don't have any jumps, we don't have to worry about vertical asymptotes, we don't have to worry about any holes because of the nature of the functions. So we'll just go ahead and check these one-sided limits. So the first one-sided limit I'm going to check is going to actually be the 0, because it's a little bit easier because this is just a 6. So we'll check the left-hand side limit as x goes 0 from the left of f of x, and the right-hand side limit as x goes 0 to the right of f of x. So if I'm looking at these two branches, the first limit as x goes towards 0 from the left is going to use the middle function ax squared plus b. And this one over here, the limit as x goes 0 from the right, is just going to use the function 6. So this is just going to be equal to 6. And if I apply this limit as x goes towards 0, this goes towards b. So what we're basically saying here is, in order for this limit to exist, the left-hand side limit and the right-hand side limit need to approach the same value. In that case, b equals 6. Off to a good start. Over here, we'll check the other limit, the limit as x approaches -2 from the left of f of x, the limit as x approaches -2 from the right of f of x. So here, this limit is going to approach -2 from the left, that's -x. Over here, the limit is going to approach -2 from the right, so that's ax squared plus b. So this, if we apply this limit, I'm going to get 2. If we apply this limit, I'm going to get 4a plus b. Now, since we know that b already equals 6, we'll just throw that in over here, and we'll get 4a plus 6. And in order for this limit to exist, the two one-sided limits need to approach the same value. That is, 4a plus 6 needs to approach 2. So in order for that to be true, 4a plus 6 to be equal to 2, 4a will be equal to -4, or a equals -1. So to conclude, in order for this function to be continuous on its domain, the value of a needs to be -1, the value of b needs to be 6. Thank you.